Greetings and welcome, friends. Mr. Waddy here. I'm just taking a look at last night's quest. We were talking in section 4.6, I believe. On page 213, we were talking about arithmetic sequences, which are lists of numbers, and arithmetic sequences specifically are ones that follow a linear pattern, although they don't make a line. They just would be points that would be along a line, okay? So here we go. Let's jump right in. I've got a good number of problems we're doing today. So it says write the next three terms of the arithmetic sequence. So it's saying that the first term is 2, all right? And it says the common difference is 13. Now, common difference, D, I was comparing that to like our slope, so to speak. Common difference is the thing that I will add to any term to get the term after it. So adding 13 is the difference between any two consecutive terms. So 2 plus 13 would be 15, would be the next term in the sequence, right? 15 plus 13, I believe, is 28, would have been the next term in the sequence. And 28 plus 13, let's see, 28 plus 10 is 38, plus 3 is 41. So 15, 28, 41 would be the next three terms in that sequence. And we got that using the common difference and the fact that we were told this is an arithmetic sequence. All right, when referring to the first term, you can also have labeled that as a sub 1 is equal to 2. What was a sub 4 in my list? Which one would a sub 4 have been referring to? The 41, the fourth term in the sequence. So that was a new notation for us. So this does not mean a times 4. This does not mean a to the fourth power. A sub 4 is in itself the entire kind of name of the variable that I'm referring to. Yeah, let me get one for you. Here's question 9. I was going to say 5, but there was a 5 there, to be fair. Here it says, find the common difference of the arithmetic sequence. So I'll show you a couple ways to do that. You could try to figure out, okay, to go from 6.5 to 5, what did it change by? To go from 5 to 3.5, what did it change by? Right? So I could try to just figure this out. All right, 6.5 to 5, it looks like it reduced by 1.5, right? And it looks like the same thing happened, minus 1.5 and minus 1.5. Okay, so my common difference, D, is negative 1.5. The other way you could have found that out, the common difference in terms of as a formula is equal to any term, I'll refer to as a sub n, subtracting the term before it, which would be 1 less than a sub n, or a sub n minus 1. And this works for any two consecutive terms, consecutive meaning side by side, terms in our list. So if I want to find the common difference D, I could have literally taken just any two consecutive terms in our list. Let's say I used these ones. So I'll say 3.5 minus 2. Sorry. Oh, no. A sub n. So 2, sorry. Minus the term before it, which was 3.5. My bad. And so I would get D equals negative 1.5. So whether you were trying to find it using the list in that way, or using this little formula for the common difference, which I don't believe your book gave you this as a formula, but in my video, I believe that I did. All right, so same result, different ways. Okay, so here we go. Let's kind of combine those skills. So here's the first three terms of an arithmetic sequence. I'm looking for the next three. They didn't tell me the common difference, so let's find the common difference, right? So let's see, common difference is going to be, I'll just do 21 minus 16. Usually I'll just pick two terms that are the smaller numbers that I could select. So 21 minus 16, it looks like minus 5 is the common difference. Or no, positive 5. What am I saying? Wow. I guess 3 days without teaching does mess with my head. So the common difference is 5. That means that I'm adding 5, which you also could have perhaps figured out by looking at the list. So plus 5, plus 5, plus 5. So now to find the next three terms in my list, well, this isn't that bad. I'm just going to add 5 repeatedly, right? So 31 plus 5 would be 36. 36 plus 5 is 41. 41 plus 5 would be 46. All right, so that's not all that difficult. What gets interesting is what happens if I ask you for the 100th term in the list. All right, which in a couple questions I'll show you how to do. So let's see. We also had you graph some of these, where you could kind of think of this in terms of what is the n of the term, right? What number term is it, and what was the term? So term number 1 is -1, term number 2 is -3, term number 3 was -5, term number 4 was -7. So if I want to graph this, it looks like these are all going negative. So I might actually make my x-axis up here, all right, and my y-axis right here. So I'm kind of in the, I know we haven't named these quadrants yet for the grid, but this is actually quadrant 4, where if you're thinking of coordinate plane, this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4, which is probably not the order that you would have thought to name them. So it kind of starts here and goes counterclockwise as you name those. Oh, there we go. So I'm going to work just in quadrant 4, and let's plot some of these points. And I'm not going to connect the dots because this is a list of numbers. There are no terms between -1 and -3. Those are the only values. So term number 1 was -1. All right, actually, let me relabel my axes here. So my x is the n, all right, and my y value is the term. Got it? Got it. So let's see, over 1, down 1 was where my first term was. 2, -3, so over 2, down 3. Let's see, 3, -5, over 3, down 5. That's another point. And over 4, down 7. Now, I realize we as humans, we kind of see a line and we want to draw the line through those, but we will not draw that line because the points in between these are not part of our list. Right? This is called discrete, where it's not continuous. It's not a continuous line or curve. Does anyone know what the common difference was for this list? They didn't ask us, but yeah, it's subtracting 2, which I also want to just point out visually on the graph, it's going down 2 for every 1 term that I increase by, down 2 over 1. So you can kind of think about the common difference as being your slope. We just aren't going to connect the dots. So if I wanted to find further terms in my list, which it does imply that this is an infinite list, down 2 over 1 and down 2 over 1, right? You could actually find more points from your list. Okay, now here is the moment of truth. This is going to be awesome. I'm pumped. This is where, all right, the power of formulas and prediction will come into play. I'm excited about this, guys. All right, write an equation for the nth term of the arithmetic sequence, then find a sub 10. Okay, so let's first label what we've got. All right, what was the first term in the sequence? What's a sub 1? 10, right? That's just our starting point. I kind of pretended this was like our y-intercept in slope-intercept form. What is the value of d, the common difference? Yeah, it looks like it's subtracting 10 for each term, right? Minus 10, minus 10, minus 10. So d is equal to -10. And then as far as a formula for the nth term, I'm going to just scroll down for a second here. We have this little formula. Let's see, I can make my inkwell disappear. It says the nth term of an arithmetic sequence with first term a sub 1 and common difference d. The nth term is given by this formula. A sub n equals a sub 1, the first term, plus n minus 1 d's. All right, so you add the common difference 1 less than n times. is the way that formula works. So I'm going to just write that formula up here. Oh, there's my Inkwell back. Thanks for coming back, Inkwell. So my nth term is equal to a sub 1 plus n minus 1 times d. So the first formula, part 1 of this, I'm just going to write my equation. Okay, so a sub n is going to equal a sub 1, which is 10, plus n minus 1 times d, which is negative 10. So I'll write that in parentheses. So it doesn't look like subtraction. I want it to look like multiplication. So this is the equation, all right? And then we probably could simplify that. So let's simplify that, all right? Which I think is what they had us do in the example. So I'm going to look at this. I can actually distribute from right to left instead of just left to right. I don't know if you guys knew that trick. 10, negative 10 times n is minus 10n, 10n. Yeah. And negative 10 times negative 1 is plus 10. And we can combine some like terms. Here we go. And I will get a sub n is equal to, I'm going to write the variable term first, negative 10n. And 10 plus 10 is 20. All right, so that's in almost like a quote-unquote slope-intercept form of that equation. Then they ask us to find a sub 10. In order to do that, I have one more variable I've got to figure out. So I've got, for this formula, I've got a sub n and I've got n. I've got to know one of those things. All right, I've got to know one of these things. If I'm looking for a sub 10, the additional piece of information I have is that n equals 10. All right, I'm looking for the 10th term, so n equals 10. And now whether I use this formula or this one, it doesn't matter. We'll use this one in this case. So I would have a sub 10 equals negative 10 times the 10th term, so n is equal to 10, plus 20. So that's going to equal negative 100 plus 20, which is equal to negative 80. Very good, very good. Let's see. How am I doing for time? Okay, I'll fit this one last example in here. So this formula is helpful in its power of prediction, that instead of just like adding 10 or negative 10 in this case over and over and over, trying to figure out when do I get to the 10th term, when do I get to the 100th term, when do I get to the millionth term, you can use a formula which will just say, hey, here's the 10th term. Don't try to keep track of counting in your head the number of times you've subtracted 10. All right, let's look at this last example. I like this one. I'll say right now, question 48 is not an arithmetic sequence. That's growing faster than we could. But if this is my first term, and this is my second term, this is my third term, let's see. Let's read the question. As each small square represents 1 square inch, determine whether the areas of the figures form an arithmetic sequence. So what is the area of this right here? That would be 1 times 1, which is 1, right? 1 times 1 is 1 for area. Let's see. So if each of these are 1 square inch, how many square inches do I have here? 1, 2, 3, 4, 5. And here I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So my list representing the areas of these figures is 1, 5, 9. Okay. And now our question is this arithmetic? And if so, let's write a function that represents it. Okay, so if it's arithmetic, well, my first term is the 1. All right, I've got that. Is there a common difference to this pattern? Is there a common difference? A number that I'm adding or subtracting? 4. Yeah, add 4, add 4, add 4. Looks like the common difference is 4. let me show you on my picture what the common difference was. So here's the middle square. All right, here the common difference was these 4 new squares that got added to it. All right, now these 5 squares exist, and the common difference was these 4 squares that got added to it. All right, so you can see that like it's just going to keep adding a new set of 4 squares on those outside branches, so to speak, infinitely is what the pattern appears to be. So let's write a function that represents the nth term. So a sub n is going to equal the first term plus n minus 1 multiplied by the common difference of 4. All right. And they wanted this in function notation. So I'm going to write this as f of n equals, and we might as well do some distribution here and simplify. Make everybody happy. Let's see, this video is getting a little bit long now. Plus 4n minus 4. I'll put the 4n first. Combine some like terms. 1 minus 4 is what now? Ooh. What's 1 minus 4 when I combine those like terms? -3. So here's my function notation. And then they asked, what is the area of the 30th figure? All right, so for the 30th figure, n would equal 30. And we'll use the function notation. So that would say f of 30 is going to equal 4 times 30 minus 3. Let's see, 4 times 30. Well, 4 times 3 is 12, and then multiplied by a 10 is 120. And it looks like f of 30 is going to equal 117. Right? And that is much faster than drawing 30 of those figures and counting their area. All right, so thanks for watching, Internet friends. Have a great day.